Hi, today we're going to be creating a basic 808 style kick inside Unreal Engine 5's modular audio environment called MetaSounds. I'm going to be using just a stock blank template with nothing in it, because we won't need much apart from the MetaSounds framework itself. So we can begin by clicking on Add, Audio, MetaSounds, and call it ms_808_kick. Double click it, and here we are. To the right, you can see a familiar set of audio tools, like a volume meter, oscilloscope, and spectrum analyzer. To the left, we've got our details panel, where the settings are stored, and in the center, the modular grid itself. Here we have our input signal, our output, and basically an empty space in between. So if you ever worked with modular synthesis before, this should be very familiar. So what we're going to need to do is create our signal generator, shape it, and then feed the audio into the output here. So we can start by right-clicking, and here in the search field you can type whatever you want. You can also go into categories and check out some stuff like filters, envelopes, like dynamics, delays, and all the good stuff. Here we have our generators or oscillators if you want. We need sine. Here it is. Here is our output. And here are our inputs. So in order to hear any sound, we need to connect our audio output with our MetaSound output, save it, and let's test it out by clicking on play. Okay, now that we've verified that our MetaSound patch actually works, we can start sound designing. First things first, we need to change our core frequency, because currently we are at 440 Hz, which is way too high for a kick, obviously. So we're gonna have to change it. Now, I've already googled that the F note at the first octave sounds at 43.65 Hz, so here's that value. You can use whatever value you want. Also, you can just drag the pin out, like so, and search for example, MIDI. So you can convert frequency to MIDI. You can also use MIDI note quantizer, basically a scale quantizer, or you can just directly control frequency with MIDI notes. I don't have any MIDI keyboard at the moment, so I'm not going to be using that. So we're going to just stick to the base frequency value for now. Let's test this out. Okay, that sounds a lot better. The next step is modulation. We need some kind of envelope to control our frequency. In order to do that, we're going to grab our input trigger, which controls our signal firing logic, and we can drag the pin out and just search for envelope, like so. Here you see your standard 80 and 80SR envelopes divided into several types, audio and float, which is kind of an important distinction in Unreal. Audio type nodes update at the sample rate, which is by default 48,000 Hz, so they're incredibly fast, whereas float type nodes are updated up to 100 Hz, if I recall correctly. Which is obviously a lot slower, but also more CPU efficient. So depending on the tasks, you might want to use one or the other. For frequency modulation, we will need audio envelope that we can just connect into the modulation pin. Now, here's where you may run into your first problem of not hearing any difference. Why is that? Well, the envelope itself doesn't know exactly what we are trying to modulate. It outputs generic values from 0 to 1. Which is way too small to hear any difference in this case, since our target parameter is frequency and needs a much higher range than that. So we will need to scale it somehow. For example, in Vital, a free wavetable synthesizer, whenever I grab one of the modulators and drag it onto a parameter, a small circle appears, which represents how much modulation I actually want to apply. So you can look at this as your minimum and maximum values. And this is precisely what we're gonna have to do inside Unreal with a special map range node. So just drag it in, hook it up like this, and let's start setting up our modulation. Let's start with the attack time, making it instantaneous, basically 0, and then we're gonna move to decay, which should be around 0.5 seconds, for example, just so we can hear it. And then we can also control how the attack curve and the decay curve behave. So keep in mind, those can change from being linear to logarithmic to exponential, depending on what you want. And I would like 0.2. And now we can move on to the map range itself. Now here it might get a little bit confusing, but just remember that inside the map range we have our A and B parameters, each with its own input and output values, where A is your starting point and B is your endpoint. So let's just set it in a binary fashion so that we start at 0 and move to 1, while the output frequency changes from the original frequency, being 0, or rather 43.65 that we set up, to the, I don't know, let's make it 1000 Hertz, for example. And let's check it out. Okay, so you can clearly hear that when the envelope fires from 0 to 1, our frequency also changes from the original frequency to the 1000 Hertz that I've just set up, which is obviously too much, so let's reduce it to something like 250. The decay is a bit too much, so let's reduce it to 0.2, for example. Yeah, that sounds better. But before we move on, you might have noticed another problem. As you can hear, the generator keeps sustaining indefinitely, even though the frequency modulation has already fired. This is because we are still lacking an amplitude modulator, which is not present by default in modular synthesizers when compared to things like Serum or Vital, where envelope 1 is by default assigned to control the volume. So let's remedy that by just calling the same onPlay trigger and adding another 80 envelope into the mix. This time though I will use a simple float, as I don't need higher speed and precision of the audio. By the way, if you're not familiar with floats, these are basically just decimal numerical values. All that's left to do now is connect these two together with the simple math. We can use multiply node, audio to float, and there you have it. I still might have to tweak the decay curve a bit, maybe make it a little more smooth and gradual. So maybe a shorter decay time and a shorter decay curve. Nice. Let's review what we've done so far. We have our frequency modulation here. We have our input trigger that runs the modulation. We have our amplitude modulation. But there is also this warning node that we haven't hooked up yet. This is a very important node in the MetaSound Source, as it directly controls when the sound actually stops being rendered. This is crucial in game audio, for example, so don't forget to hook it up to your on-done execute pins. Otherwise your audio will just keep rendering forever, even though you can't hear it. Okay, since we've got the base of our sound covered, we can now play around with the tone of it. Classic way to make 808s hit harder is distortion. In this particular example, I'm gonna be using Sine Compression, but you could also achieve that with Wave Shaper node. Since distortion happens when an audio signal exceeds a certain range, causing the waveform to be reshaped or clipped, let's just set that range with a simple compressor. Now the trick is to set it up properly, so let's increase our ratio to 100, let's lower our threshold. Somewhere about -20, I guess. Now the main action comes from very fast attack and release times, which will start to make the distortion audible. So let's set our attack at 0, and we will play around with release time next. You can hear it's super quiet, so let's maybe add a limiter, mainly just to boost the volume and act as a, well, limiter. 10 dB. Okay, maybe 20 dB. Yeah, there it is. You can already hear it. So now when I tweak the release time, we can actually shape the waveform the way we want to. So for example, let's put it to 0.001. There we go. Okay, let's play around with it. Alright, let's leave it at that for now. We should also tweak look ahead to be off, basically, and have a hard knee. The rest of the settings seem to be okay. Cool. So we're finally getting closer to the desired sound. One more thing we could do to dial in the perfect tone is to tweak our release time some more. But I would suggest you do that with macros, or what's called graph input node in Unreal. Super handy stuff. So with this, I can then tweak my parameter just by dragging the knob. But because the parameter range is so high, we almost don't hear any difference. So let's just check the detail panel and set our default value at 0.002, for example. So this will be our minimum default value. And the maximum value, let's set it at 0.01 and check to see what happens. Now that's more like it. So let's recap what we have built so far. So this is gonna be our frequency modulation. I can press C on my keyboard and write a comment for pitch modulation. Then we have our amplitude modulation. Same thing, press C, comment, amp modulation. And this guy is gonna be our distortion unit. So, well, distortion. Now we can finish tweaking the parameters and maybe rename it. For example, distortion, or maybe tone is better. Save it and check. Maybe a little more, release. Yeah, okay, I'm pretty happy with the result. So this is it. This is how you make a simple 808 kick, or bass if you want to, inside Unreal Engine, just in case you wanted to for whatever reason. Hope this helps, and bye.